Hey y'all, we are going to do some extra practice right now. So the first thing we're going to do some extra practice on is segment lengths in circles. Alright, so in this first example, it wants you to find the value of x. So we have to ask ourselves, well, what are we given? And in this case, we're given two chords. Remember, a chord is something that goes across the circle. It has endpoints on the side of the circle. So these are two chords. So I'm going to go ahead and color code our two chords. We have this yellow chord, and its values are x and 2x. And then we also have this green chord, and its lengths or values are 9 and 8. Alright, so when we do a problem like this, our formula is part times part equals part times part. So go ahead and pause the video for a second and see if you can plug it in correctly. You just need to be careful that you have to get the parts from the same line on the same side of the equation. So pause the video and try it. So when I did part times part equals part times part, I got x times 2x, that's from the yellow chord, equals 8 times 9, and that's from the green chord. So now we just need to solve the equation. So again, I want you to pause it and try to solve this equation on your own. Alright, let's check your work. If you do x times 2x, that's going to give you 2x squared. And x times an x is an x squared. And then 8 times 9, it's going to be 72. We're trying to solve for x, so we need to get rid of the 2, so I would divide each side by 2. Kind of running out of room, so I'm going to shift it over here. Oops. Alright, so 72 divided by 2 is 36. And then we still need to get rid of the square because we want the x to be by itself. So the opposite of squaring is square rooting. When you take the square root of 36, you get a positive and a negative 6. But since it's asking for the length of x, it can only be positive. So in this case, the side length, or the value of x, is 6. So if it had asked us for this length, you would have plugged 6 back in, and this length here would have been 12. Alright, so take a minute and try to set up this equation. Pause the video, set this one up. Alright, so when I set it up, I got 4 times 3 equals x times 6. It doesn't matter if you have, x times 6 first or 4 times 3 first. It's going to solve the same way. So from here, we would distribute, or we would multiply. 4 times 3 is 12, x times 6 is 6x. You could divide each side by 6, and x would equal 2. Alright, let's try a couple more. So this problem looks different for sure. I don't have chords. I have this line goes inside and outside of the circle. That's a secant. It's a line that goes all the way through the circle, touches in two places. And then I also have this line. And this line, if you think about extending it, it would only touch the circle in this one spot. So that's a tangent. Alright, so when you see a problem like this, for this secant line, the part that goes inside and outside, your formula is outside times the whole segment. And then for this one over here, you're just going to take that tangent and square it. So I'm going to abbreviate it as tan squared. Alright, so pause the video and try to plug those values in. Alright, so when I plugged them in, the outside of my secant line was 4. And then you have to be really careful. 12 is not the whole line. 12 is only the inside value, and we don't want to know the inside value. We want to know the whole line. So we have to add those two pieces together, the inside plus the outside, to get 16 for the whole line. And then the tangent squared was just x squared. So go ahead and finish out solving this. Pause the video and try it. So when I finished it out, I got x equals 8. 4 times 16 is 64, and then to get rid of the square, you would square root it, so x equals 8. Alright, let's look at this next problem. Notice here you have an inside part and an outside part, and then here you have an inside part and an outside part. Those are two secants, so you're going to use outside times whole for both of them. So we would go over here and we would write our formula. Outside times whole equals outside times whole. So go ahead and pause the video, try to substitute it in, and solve it. Alright, so here's what I got. I got 14.3, and this is the step that I want you to pay super close, careful attention to. Remember, the outside value is 3. That's pretty straightforward. But then the whole value is not x. X is only the inside piece. So to get the whole distance, you would need to add those two things together. Alright, same thing over here. Pay really close attention to this. 4 is the outside piece. And then to get the whole distance, you would have to add 4 plus 9. That's where 13 came from. And then you just have an equation to solve. You would distribute the 3, and you would multiply 4 times 13. Then I subtracted 9 from each side, and then I divided by 3 on each side. So your answers could be written as 43 over 3, or approximately 14.3. Okay, so we're going to do one more example. This time we're going to talk about angle and arc measurements. We're not talking about side lengths. You have to keep those straight in your mind. So the first question says, what is the measure of arc AB? So I'm going to go over here and I'm going to color code arc AB. And then I'm just going to look at my picture and try to use what I know. The only thing I'm given so far is that angle D, that angle ADB, is 34 degrees. But I can actually use that to find my arc because the vertex of this angle is on the circle. So it would be angle equals half the arc. Or you could also say the arc equals the angle times 2. So if this arc has to be twice as big as the angle, you could just multiply 34 times 2, and that arc AB is going to be 68. Alright, the next question says, what is the measure of angle BCE? I want you to pause the video and try to figure that one out. Okay, so I got 34 degrees. So what I did is I highlighted BCE. And I realized that even though it stopped at E, that angle really does continue on. So then I noticed that it intercepts this arc that's 68 degrees. And I know that the angle, since it's on the circle, the vertex is on the circle, the angle has to be half the arc. So I just plugged it in. I also could have taken a shortcut and I could have said, well, since this angle intercepts arc AB and this angle intercepts arc AB, those two angles have to be equal. Alright, the last one we're going to do, it says, what is the measure of angle DEC? So go ahead and pause the video and see if you can figure it out. Alright, we're going to work through this one together. It says the measure of angle DEC. So I went ahead and highlighted DEC. And I noticed that the vertex of that angle is inside the circle. It's not on the circle and it's not in the center of the circle. So our rule for inside the circle is where we make the bow tie. So I'm going to go ahead and finish out my bow tie here. It's kind of like a straight up and down bow tie. It's been turned. But once we create that bow tie, our formula is angle equals 1/2 of the arc plus the arc. So we're talking about this arc, which is 68, and this arc, which is 200. So we can just plug in our values. 68 plus 200, and then we can solve it from there. 68 plus 200 is 268, and half of 268 is 134. So the angle right here equals 134 degrees. And the cool thing about that is these are vertical angles, so I know that's also 134 degrees. And then if I wanted to find this angle, those are supplementary, so I could subtract from 180. So once you find one of them, you can kind of find all of them. So that one would be 46, and then its vertical angle would be 46. All right, that's it for our additional practice. I hope this helped.